Alright, in this video we'll be looking at solving logarithmic equations. First one we have is log base 3 of 9 plus log base 3 of x plus 2 is equal to 4. And what we're trying to do here is we're trying to solve for x. So the first thing we're going to do is use some of our properties to combine these two logs, make a single log out of that. So we're going to use the property that says that addition is the same thing as multiplying these two terms right here. So now I've got the log base 3. I'm going to multiply the 9 and the x plus 2. And if I multiply 9 times an x plus 2, I end up with a 9x plus 18. So again, all I did was multiply 9 times x plus 2. Still equals to a 4. Once I rewrite this as a single log expression, the next thing I'm going to do is rewrite this as an exponential. So this log is now going to become the exponential 3 to the 4th power equals 9x plus 18. And again, we've already covered this in a previous video, changing from a log to an exponential. So now what we're going to do is go ahead and take that 3 to the 4th power and change that to 81, because that's what 3 to the 4th power is. And all we're going to do now is we're going to solve for x. So we're going to go ahead and subtract 18. So 81 minus 18 would be 63. Now we're going to divide by 9. And 63 divided by 9 would be a 7. Therefore, the solution of this equation is x equals 7. Example number 2. We have the equation log base 5 of x minus log base 5 of 2 equals 3. First thing we're going to do is combine these two logs as a single expression. So if we use the property that says that subtraction is the same thing as taking these two terms right here and dividing. So we're going to rewrite this as the log, keep the same base 5, and we're going to divide these two terms right here. So we're going to do x divided by 2 equals 3. So all I've done is rewritten the two logs as a single log. Now what we're going to do is rewrite the log as an exponential. So the exponential now becomes 5, that's the base, to the 3rd power, that's our exponent, equals x over 2, our argument. Now we're going to go ahead and take that 5 to the 3rd power. That 5 to the 3rd power now becomes 125, because that's what 5 to the 3rd power is. Now what I'm going to do is I'm going to solve for x. The opposite of dividing by 2 is to multiply by 2. So now we have x is equal to 2 times 125 would be 250. Therefore, the solution of this equation is x equals 250. Okay, number 3, we have 4 times the log base 9 of 3 equals x. First thing I'm going to do is use the property that says that this 4, the multiplication, is going to become the exponent. So this now becomes log base 9 of 3 to the 4th power equals x. Now, of course, if I go ahead and do 3 to the 4th power, 3 to the 4th power is 81. So I now have the log base 9 of 81 equals x. We're now going to change that log to an exponential, and that exponential now becomes 9 to the x power equals 81. And we're solving for x. What exponent do I need to use on 9 so that I end up with an 81? 9 to the what power gives me 81? In this case, that exponent needs to be a 2, because 9 squared would give me 81. Therefore, our solution to number 3 is x equals 2. Okay, number 4, we have log base x of 12 plus log base x of 18 equals 3. First thing we're going to do is combine the two logs, make it a single expression. So we're going to use the property that says that addition is the same thing as multiplying these two terms here. So this now becomes log base x of 12 times 18. And if I multiply 12 times 18, I get 216. Still equals 3. Now I'm going to take this single log and rewrite it as an exponential. So this is now going to become x to the third power equals 216. And since I'm solving for x, I want to know what number can I cube to get 216. Now remember, the opposite of cubing something is to take the cube root. So what I'm going to do is take the cube root of 216. And the cube root of 216 is 6. Therefore, our solution to this equation is 6.